So very good afternoon to all. So in this principle of operating system, we are going to see a topic of multi-programming versus multitasking in operating system. Myself, Farooq Abnes from third year EC. So let's get into the video. In this video, we will understand how operating system manage multiple programs and deliver responsive user experience to the efficient resource utilization. Let's get into it. So coming to the core of goals of operating system, this minimizes the CPU utilization and provides user responsiveness. Coming to the minimized CPU utilization, this keeps the processor busy as possible, and ideal CPU presents wasted computational resources and reduce its system efficiency. Then coming to the provide user responsiveness, this system feels fast and interactive for user, and quick response creates the seamless and computing experience. Then these fundamental objectives drive these designs of both multi-programming and multitasking system, forming the foundation of modern operating system architecture. So, coming to the understanding multi-programming, this keeps the program or jobs loaded in the memories and allowing the CPU to switch between them efficiently. How it works? First of all, it comes in CPU executes one program until it encounters in its waiting states. Then coming to common wait triggers, which includes the IO operations of disk reads. Then OS immediately switch the CPU to another ready program. Then this CPU does not have waste its time on idle waiting. So coming to the next one, multi-programming on the chief analogy. So first is it imagines preparing. Imagine that a chef is preparing a meal when the water is boiling instead of standing and idle. The chef chops vegetables whether when the water boils, and also the chef shifts the back to for cooking pasta. While boiling the water, the chef even chopping the vegetables like that. Other works is doing. No, that is called as the multi-programming. Then coming to the start pasta water boiling, then it begins with the begin IO intensity task. Then switch chopping to vegetables, which also related to the CPU switch to another job. Water boils, it returns to pasta. That is IO complete and resume its original task, which results the CPU stays continuously busy, reducing its total meal preparations time significantly. So coming to this multi-programming performance its benefits, then which increase the output, then better resources, then utilization, then a real world example which we'll see in the last. Coming to the increases throughput, more jobs completed in the same time period, and the CPU idle time is converted into productive work, dramatically improve its overall system output. Better resource utilization. Resources like CPU and memory are used optimally. When one program is runs in the disk, another utilizes the processor. Coming to the real world example, that banking system like that we have saw no process that accounts update while generating reports backing up data seamlessly, minimizing its overnight processing efficiency. So coming to the understanding of multitasking, there are three types. One is time division, rapid switching, and parallel illusion. Coming to time division, CPU divides its time into smaller sizes called time quanta into milliseconds. Then rapid switching is voice rapidly switch between the program, like that we switching the tabs now like that, giving us each time for slice to turn. Parallel illusion means it creates the illusion in all the program runs that seamlessly. Coming this primary goal, which coming to a goal, this minimizes the system responsiveness and user interaction capability. Coming to multitasking, the chess master analogy, we will see in the chess master analogy that a chess master plays the 10 opponents simultaneously, moving from board to board and moving one move at a time. Each opponent receives a small slice now of utterance in a round robin fashion. Okay, coming to this, that player 1, player 2, player 3 and continue. This will rotation the part. Okay. Coming to this multitasking benefits, it enhances the enhanced user experience, and real world example we will see last. In enhanced user experience, dramatically improve the system responsiveness, and it does not wait a long time to complete its task. System feels fast and fluid. Then multiple application can also run seamlessly. In real world application, we said that your current computing experience using a web browser, music player, like that. I am playing my music in my web browser and doing my coding in the VS Code. Like that, we can say an example. So coming to the head-to-head comparison, the feature is a first of all primary goal, then a switch trigger, then a core concept. The color has been mismatched. So coming to the primary goal, here minimizes the CPU utilization, then minimize user responses, both the multi-programming and multitasking. Then coming to the switch triggering, this process enters a white stage, then time slice experience, then also non-interactive, then here I interactive. Coming to core concept, in multi-program we see context switching, in multitasking we see that the time sharing and context switching. So coming to the end of we have see about the multi-programming foundation, then the evolution, then integration. In a multi-programming foundation, lay the groundwork by introducing a busy waiting elimination, which focus on the efficiency and resource utilization. Coming to multitasking evolution, advanced multi-program with time slicing or interactive process focus on the user experience and responsiveness. In integrated approach, modern OS like both the techniques of multitasking, system build, which I said an example, multitasking, multi-programming principle for optimal efficiency and responsiveness. So in this today's operating system, we don't choose over the other. They seamlessly combine both approaches to deliver the ultimate computing experience in nowadays. So that's all. Thank you.